Hello my viewer, it is an honor having you on board. This is Dixon from MathsWiz, where we teach mathematics and mathematical sciences. Please join me for this lesson, learn, understand and enjoy maths with me. If you are new to our channel, please remember to subscribe to be our student and get our future lessons immediately they are released. This is our fourth lesson in the series Chemical Equations. In this lesson we are going to learn how to write ionic equations. The introduction to this lesson is 1. Ionic equation is a chemical equation that contains only the ions that undergo a change in a chemical reaction. Basic information in writing ionic equation includes: A. Know that molecular compounds in an equation are in solid, liquid or gaseous states, either as reactants or products, should not be split into free ions. B. Compounds that are soluble in water dissociate to form free ions when dissolved in water. Number 3. Identify cations and anions in a compound and assign the charges using periodic table of ions. In writing ionic equations, we are going to follow the following steps. Step number 1, write the balanced chemical equation for the reaction. Step number 2, identify the compounds that contain free ions. Step number 3, rewrite the chemical equation in step 1 in ionic form. And step number 4, write the equation in step 3 and omit the ions which appear on both sides of the equation as free ions. Examples of writing ionic equations. These examples will be based on the methods of salt preparation. Under method number 1, we have acid metal reaction. Our example is magnesium metal reacting with the dilute sulphuric acid. We start by writing the chemical equation for this reaction, and we have magnesium metal plus sulphuric acid to give magnesium sulphate plus hydrogen gas. The equation is balanced. We now go to step number 2. We rewrite the equation and we show ions present in aqueous solutions. With that, we have magnesium is a solid, so it is not going to have free ions. From the acid we get 2 moles of hydrogen ions and 1 mole of sulfate ions. From magnesium sulfate we have 1 mole of magnesium ions and 1 mole of sulfate ions. Hydrogen is a gas, so no free ions, so we have H2 gas. We now cancel the ions that appear on both sides of the equation. With that, we have the sulfate ions appear on both sides. Therefore, our ionic equation is magnesium in solid form plus 2 moles of hydrogen ions to give 1 mole of magnesium ions and 1 mole of hydrogen gas. In the second category, we consider the second method of salt preparation, that is acid-base reaction. And it's important to remember, when an acid reacts with a base, a neutralization reaction occurs. The first example in this, we have dilute nitric acid react with potassium hydroxide solution. So therefore, the equation is dilute nitric acid plus potassium hydroxide to give potassium nitrate and water. Our equation is balanced. We go to the next step. We split the aqueous solutions and present the free ions on each side. That is, the nitric acid ionizes to hydrogen ion and nitrate radical. Potassium hydroxide ionizes to potassium ions and hydroxide ions. Potassium nitrate solution will give us potassium ions and nitrate ions. Water is in liquid form, so therefore there are no free ions. We now remove the ions that appear on both sides of the equation. 1, we have the nitrate ions, and the potassium ions also appear on both sides of the equation. They are eliminated, and the ions that remain make our ionic equation, and that is hydrogen ions plus OH ions to give 1 mole of water, and that is our ionic equation. Our second example in this method of salt preparation is dilute hydrochloric acid plus copper 2 oxide, and the equation is dilute hydrochloric acid, that is HCl, plus copper 2 oxide CO solid form to give us copper 2 chloride in aqueous form plus a mole of water. We balance our equation. The chlorides are 2 here, we make them to be 2 on the left hand side. Hydrogens are 2 on both sides, and our equation is balanced. We now rewrite the equation showing removing the free ions in each of the substances. From hydrochloric acid, we have 2 moles of hydrogen ions and 2 moles of chloride ions. Copper 2 oxide is in solid form, so no free ions, to give copper 2 chloride, that is Cu plus 2 chloride ions, and lastly we have water molecule. We now cancel the ions that appear on the right and left hand side of the equation. Hydrogen ions, they are only present on the left. Chloride ions, they are left on the right and left hand side, so therefore they are spectator ions and no other spectator ions. Therefore, our equation becomes 2 hydrogen ions plus copper 2 oxide in solid form to give us copper 2 in ionic form plus a mole of water. And that is our ionic equation for the reaction between hydrochloric acid and copper 2 oxide. We are now in the third method of salt preparation, where we are going to write the ionic equation for acid metal carbonate or acid metal hydrogen carbonate reactions. The first reaction, we have zinc carbonate plus dilute nitric acid. We write the equation for this reaction. Zinc carbonate is ZnCO3 solid form plus dilute nitric acid HNO3. Our products are zinc nitrate, carbon 4 oxide, and water. We balance the equation that we have written. We realize on the right hand side nitrates are 2, left hand side it is 1. We make them to be 2, multiply the acid by 2. Hence the hydrogens are 2 on both sides, carbon is 1 on each side, oxygens are 3 on each side, so therefore the equation is balanced. Step number 2, we convert the equation to ionic format, whereby we have zinc carbonate is a solid, so therefore remain. The acid will dissociate to free ions, that is free hydrogen ions and free nitrate ions. On the right hand side we have zinc nitrate will give free zinc ions and free nitrate ions. We have carbon 4 oxide gas and water. We now cancel the ions that appear on both sides of the equation, that is we have nitrate ions are present on right and left hand side, no other free ions, meaning that our equation is zinc carbonate plus 2 hydrogen ions to give zinc ions plus carbon 4 oxide plus water, and that is the equation for our reaction. In the second example under this category, we have sodium hydrogen carbonate plus dilute sulphuric 6 acid, and the equation is sodium hydrogen carbonate is a solution in water plus dilute sulphuric acid to give us sodium sulphate plus carbon 4 oxide plus water. We balance the chemical equation that we have. Sodium are 2 on the right hand side and 1 on the left hand side, so we multiply sodium hydrogen carbonate, the whole molecule, by 2. That makes sodium to be 2, carbon to be 2, so therefore we multiply the carbon 4 oxide by 2. The hydrogen 4 on the left hand side, 2 on the right hand side, we multiply by 2 on the right hand side, and therefore our equation is balanced. In our next step, we show ionization in each aqueous solution, that is sodium hydrogen carbonate will give 2 moles of sodium ions and 2 moles of hydrogen carbonate. The acid will give 2 moles of hydrogen ions and 1 mole of sulfate ions. The sodium sulfate will give 2 moles of sodium ions, 1 mole of sulfate ions. Then we have 2 moles of carbon 4 oxide and 2 moles of water. We now cancel the spectator ions, the one that appear on the right and left hand side. 2 moles of sodium ions are on both sides of the equation. Sulfate, 1 mole of sulfate on each of the side, cancel. Hence our equation is 2 moles of hydrogen carbonate reacting with 2 moles of hydrogen ions to give 2 moles of carbon 4 oxide and 2 moles of water, and that is our ionic equation. And the fourth method of salt preparation, that is precipitation, or we call it ionic exchange, or we also call it double decomposition method. We have our example is barium nitrate solution reacted with ammonium carbonate solution, and our equation will be barium nitrate in solution form plus we have NH4 into brackets 2CO3 aqueous to give us ionic exchange reaction occurs. Barium takes carbonate and we have barium carbonate and ammonium nitrate solution. The nitrates and ammonium are 2 on the left hand side, so we also make them to be 2 on the right hand side. Then after that we write each of the substance in solution equation form, we write the ions present. In barium nitrate, we have barium ions plus nitrate ions, 2 moles, plus 2 moles of ammonium radical plus 1 mole of carbonate radical, which will give us barium carbonate plus 2 moles of ammonium ions and 2 moles of nitrate ions. We now cancel the ions that appear on the right and left hand side of the equations. So we start with the nitrate ions. They appear on right and left hand side. Then we have ammonium ions. They appear again on right and left hand side, meaning that our ionic equation is barium ions plus carbonate ions to give us barium carbonate precipitate. In the fifth method, we are going to consider displacement reactions or redox reactions. And in this example, we have zinc metal plus copper 2 sulphate solution, whereby we have the equation is zinc metal plus copper 2 sulphate solution. Since zinc is more reactive than copper, it is going to displace copper from the sulphate, and we are going to have zinc sulphate plus a copper metal. In the next step, we write the ions that appear on each of the sides. We have zinc plus copper ions in solution plus sulphate ions to give us zinc plus sulphate plus a copper metal. We now cancel the ions that appear on the right and left hand side of the equation. We have the sulphate ions are the only ions appearing on the two sides, meaning that our ionic equation is Zn solid plus Cu2 plus ions to give us Zn2 plus ions plus a copper metal, and that is the equation for our reaction. This is Dixon again from Maths Whiz. It is my hope that you have learned, understood and enjoyed the lesson. Please remember to subscribe to our channel and give us your feedback from the lesson. Thank you for your watching.